In this video, we are going to do 17.01 peaks. Okay, so I have the problem opened up in Racket. So let's just look for the problem statement here. In a list of numbers, a given element is called a peak if it's strictly larger than all the numbers that come after it in the list. Write a function peaks that consumes a list of numbers and produces a sublist consisting of all the peaks from the original list. And here's an example, all right? So peaks on the list 1, 6, 4, and 5 should produce the list 6 and 5. Why? Because 1, right? Let's go through this number by number. So is 1 greater than all the numbers in the rest of the list? No, right? 6 is larger than 1, and likewise there's like no other bigger number, right? Like so, right? So 6, is 6 bigger than all the numbers in the rest of the list, right? 4 and 5, yeah. 6 is bigger than 4. And 6 is bigger than 5, so it gets put in the sublist here, right? Is 4 bigger than all the numbers in the rest of the list? Well, there's only 5 in the rest of the list from this point forward, right? So, no, right? 5 is bigger than 4, so we're not going to put 4 into the sublist, right? And is 5 bigger than all the numbers in the rest of the list? It is, right? At least for this problem it is, right? There are no other numbers in the rest of the list, so therefore we consider it a peak, right? So that will be that 5 there. And we produce this list. You'll need a helper function that determines if a number is larger than the rest of the list, right? So this is a huge hint that you need to break things down into another function here. And likewise, they give us the signature and the purpose for peaks. Anywho, pause the video and try to work through the solution for peaks on your own. I'm going for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So they did the signature and the purpose for us already. Let's just stub this out. But find peak consumes a number list and produces a list of numbers, so we'll use empty as a dummy value. All right, so here's some tests to illustrate how this function will work. So peaks of empty should just produce the empty list. We'll do another one that is check expect. Peaks of cons2 empty, right? So since there's only one number in this list, we consider it a peak. So we should produce the list cons2 empty, okay? Next, let's do one that's too long. So peaks cons7 on the cons, let's say 1 empty, right? So 7 is bigger than all the numbers in the rest of the list. And 1 is also bigger than the numbers in the rest of the list. Wait, except, when we get to the 1 case, it's the only number left. So nonetheless, we still consider it a peak. So we should produce the list cons 7, cons 1 empty, right? All right, let's actually reverse this. All right, so let me just reverse this. So instead, we're going to have cons 1 and then a 7. All right, so is 1 bigger than all the numbers in the rest of the list? No, there's a 7 afterwards, and that 7 is bigger. So we're not going to include the 1 in the rest of the list. We should just produce cons 7 empty in this case for this list. And for the 3 element long case, I explained it earlier. We're just going to copy and paste this and make this a code example. All right, so this should produce the list 6 and 5. Because, yeah, 1 is not bigger than 6. 6 is bigger than 4, so we'll keep it. 6 is bigger than 4 and 5, I mean. So we'll keep that in the result here. And 5 is bigger than the rest, but it's, the last item in the list, which we will always consider to be a peak. Okay. Anywho, let's just run it against our stub here. Just mismatches, that's fine. Comment this out. Gonna grab the template up here. And we're gonna start. Okay. So now really pause the video. Hopefully this should be all the mental scaffolding needed to solve the problem for peaks. All right. Hint, you're going to need to write a helper function, so you got to decompose this task here. Anyways, I'm going to go with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. Okay, so looking at our examples here, if we consume empty, we produce empty. All right, that's just the base case. Now comes the hardest part, looking for the combinator. So let's just look for the examples here. Maybe it'll tell us something about it. So if we consume 7 and 1, we produce 7 and 1. But if we consume 1 and 7, we just produce 7. And for this, right, we produce 6 and 5 because they are bigger than the rest of their respective lists, and we exclude 1 and 4. So sometimes we're including numbers, sometimes we're not. That kind of sounds like some decision making is going on here. So we're going to need an if, because if is what does branching on decisions, right? All right, so if some number, right? So let's look at these simple examples first, right? So 7 is, is 7 bigger than the rest of the list, right? So this is going to be that 7, but how do we ask if it's going to be bigger than the rest of the list, right? Well, we just have to imagine that function exists, right? We're going to imagine this task, larger than rest, question mark. So this is going to be that 7, and is it larger than the rest of the list, right? Rest of the num-lst. Okay, like so. All right, so if it is larger than the rest of the list, we want to include it in the output, right? We want to produce a new list for the peaks, right? So in this case, we want that number, right? This is going to be that 7. When it cons it onto what we assume will be peaks working on the rest of the list, right? Like so. Otherwise, right, so if has 3 parts, this is the condition, this is the true branch, and this is the false branch. Otherwise, right, we want to call peaks assuming that it will work and continue on for processing the rest of the list, right? So in this case, we include the number, right? So this is what's gonna include the 6 and the 5, and then this false branch is what discards numbers 1 and 4, right? And these are the cases, right? This case, it discards the 1. All right, so we run this code. It's not going to work just yet. We have to write this function larger than rest. We pretended it exists, right? It kind of makes things easier to compartmentalize if we write the code first, right? The function call first, right? Because the structure of the code is there. We just have to write the functionality. So larger, than rest. Question mark, right? Consumes the number, a number, any list of number, and produces number, a boolean. All right, the purpose is that produces true if the given number is larger than any number in the given list, right? If this number is bigger than any number in this list, okay? All right, so signature, purpose, let's stub this out. Define larger than rest, question mark, consumes a number, we'll call it val, and then we're calling this number input parameter val, and then list of number as num-list. Produces a boolean, so we'll write false as a dummy to run against some tests here. Larger than rest, question mark of 4, let's say 4 and empty, right? Is 4 bigger than all the items in the given list here of empty, right? Well, it is, right? Even though it's an empty list, we consider it bigger than, any item in the rest of the list because there's nothing else here. All right. It's weird, but that's what we got to do. So larger than rest. We'll do another example here of 2 cons 1, cons 2, and a cons 3 empty. Okay. All right. So is 2, right? This 2, is it bigger than all these numbers in this list? No, right? It's bigger than 1, but it's not bigger than 2. It's equal to 2, and it's less than 3. So this should produce false. Let's do one that's passing, right? So check expect. Larger than rest of 3, cons 1 on cons 2 on cons 0 empty, right? All right. So is this 3 bigger than all these numbers in this list? It is, right? It's bigger than 1, it's bigger than 2, and 3 is bigger than 0. So we should produce true for this function. So we're going to get to a stub here. We get a lot of mismatches. Looks like there are no errors here. It's fine. We're going to comment this out. And we're going to grab the recursive template that consumes a list of number. Like so. Put that down here. And rename it. Okay, so now really pause the video and try to work through the solution for larger than rest. I'll go over spoilers in 3, 2, and 1. All right, hopefully that was all the mental scaffolding needed to solve the problem. So I made a mistake here. I forgot to put the number here, right? Because this function consumes 2 arguments and the template only has 1 argument, the num list, right? So I'm going to add the val, right? We're consuming a number and a list of number, okay? All right. So looking at our examples here, right? So we give it an empty list, we produce true, like so. All right, so now comes the hardest part, right? Finding the combinator for the else case, right? What happens when we are processing a list with things in it. So what we need to do actually is we need to compare the number that we're given to each individual item in the list here, right? So the number that we're given is stored in val, and you want to compare it with the first of each individual item respectively, right? So that would be the first here. So what we want to know is if it's bigger, right? If it's greater than every number, right? Every respective number through every recursive call. Okay? So since this is a Boolean, right? We only could, use functions that consume and produce Booleans. So if consumes a Boolean for the first condition, right? Condition, and then a true, and then what to do in the false case, right? So if val, right? So let's look at this case here, right? Is 2 bigger than 1? Yeah, it is. Is 2 bigger than 2? No, it isn't, right? And is 2 bigger than 3? No, it isn't, right? So that would be the false case here, right? So in that case, right, we're done. We actually don't need to look through the rest of this list, right? So this can just be false. All right, so I'm going to delete this case up here because we're going to need the recursive call. Otherwise, right, what we need to do is we need to call larger than rest on the rest of the list, right? Because 2, it's bigger than 1, but there's still other numbers in the list, so we have to keep looking at the rest of this list, right? We can call larger than rest on the rest of the list, which we will assume will fulfill its purpose statement, right? Because again, 2 is bigger than 1, but we have other numbers and we're not sure if they're bigger than 2, right? In this case, we do know because we see it right here. But, when in the execution of the function doesn't know until it recursively calls it and encounters it. Anyways, let's just run everything and see if it passes. Larger than rest, it expects 2 arguments, only found 1. Oh, yes, I forgot to pass in the number here, right? Because larger than rest takes in 2 arguments, and that number comes along for the ride. And all 8 tests pass for larger than rest and peaks, right? So notice that again, we broke peaks up into another function, a helper function, right? And we just pretended that it existed, and it made things a lot easier to reason about. Anyways, you can use the stepper, comment things out, comment some tests out, and to step through things. If you're curious how it works at a mechanical level, use the table method, etc. All right, submit this into Handin and make sure you pass the greater side tests. And yeah, that is about it for this video, and I will catch you in the next one.